Greetings, welcome to this new video about superposition theorem, solving problem number 9. In this video, I will demonstrate the application of the superposition method to solve a problem, and I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of 3 resistors labeled R1 through R3, as well as 3 independent sources. The question now is to use superposition method to find the voltage VO across the resistor R3. Let's move on to the solution. First, we begin by identifying each independent source in this circuit. This step provides a clear understanding of the source that will be analyzed separately. In this circuit, we can observe 3 independent sources, 2 independent current sources IA and IB, and 1 independent voltage source VS. Next, we proceed to deactivate all but 1 independent source in the circuit. This involves replacing the inactive voltage sources with short circuits, which means it's zero voltage, and the current sources with an open circuits, which means it's zero current. Let's begin first by activating the independent current source IA and deactivating the independent current source IB and the independent voltage source VS, which will be replaced respectively by an open circuit and a short circuit. The next step is to solve the circuits using conventional techniques. In order to calculate the voltage V1 across R3, we need first to calculate the current I through the resistor R3. The current I can be calculated using the current division rule, which means I is equal to R1 over R1 plus R2 plus R3 times IA. And if we replace the resistors and the current with their numerical values, we obtain I is equal to 869.56 milliamps. According to Ohm's law, the voltage V1 across the resistor R3 is equal to R3 times I. If we replace R3 and I with their numerical values, we obtain V1 is equal to 4.347 volt. Now let's consider the independent current source IB active and the independent current source IA and the independent voltage source VS inactive, which will be replaced respectively by an open circuit and a short circuit. In order to calculate the voltage V2 across the resistor R3, we need to find first the current I. The current I can be calculated using the current division rule, which means I is equal to R2 over R1 plus R2 plus R3 times IB. And if we replace the resistors and the current with their numerical values, we obtain I is equal to 1.39 amps. According to Ohm's law, the voltage V2 across the resistor R3 is equal to R3 times I. If we replace R3 and I with their numerical values, we obtain V2 is equal to 6.95 volt. Now let's consider the independent voltage source VS active and the independent current sources IA and IB inactive, which will be replaced by open circuits. In order to calculate the voltage V3 across the resistor R3, we need to calculate the current I. The current I can be calculated by applying Kirchhoff's voltage law. In this loop, we can write R1 plus R2 plus R3 times I plus VS is equal to 0. And if we replace VS and R1 and R2 and R3 with their numerical values, we obtain I is equal to negative 521.74 milliamps. Now, according to Ohm's law, the voltage V3 is equal to R3 times I, and if we replace R3 and I with their numerical values, we obtain V3 is equal to negative 2.6 volt. After completing the analysis for each independent source, while treating the other as turned off, the subsequent step is to combine the results algebraically. This process enables us to determine the overall circuit response. That means VO across the resistor R3 is equal to V1 plus V2 plus V3. And if we replace V1, V2, and V3 with their numerical values, we obtain VO is equal to 8.7 volt. After completing the calculation, we conduct a simulation using a SPICE simulator in order to verify our calculation. Let's proceed now to the SPICE environment. Here is our network drawn in the SPICE simulator. We can see here this is the independent current source IA, the independent current source IB, the independent voltage source VS, resistor R1, R2, R3. I connect here a voltmeter in order to measure the voltage VO across the resistor R3. If we go to analysis, DC analysis, calculate nodal voltage, we can see here that the voltage VO is equal to 8.7 volt. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves a validation of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about superposition method. Take care and bye-bye.